All right, what I want to do is I'd like to introduce you to electronics. And the first thing that I want to do is this subject area is really just an extension of electronics from first and second year. So in fact, what we're going to do is we're going to review a lot the components that you looked at and worked with in first and second year. And really, they become the building blocks for a lot of the components that we're going to use now in third year. So what I'd like to do, I want to give you a little bit of a flow chart that shows you how this is going to be laid out, and kind of in what order we're going to go at attacking these things. All right, now let me just start at the top. And in that box up there, this is the third part really of this. Okay, so year 3 electronics, and what I'm going to do is I want to start by just extending this over, and the first thing that we're going to talk about is a review of atomic theory. Okay, so atomic theory, we're going to dig into that a little bit. Remember some of the stuff about the nucleus, the valence shells, and so on. Well, once we've gone through atomic theory, we're going to move and we're going to relate that into P and N type materials. P and N type materials. And once we've talked about that, then we're going to move and we're going to say once we have our P and our N type materials, we're going to move to what are we going to do with those? Well, we're going to put them together in what we call PN junctions. PN junctions. Now, PN junction is a diode, but there are many other ways of combining PN junctions together in more than 2 layers, and those are the basis of several other types of components. So not only there won't be just the diodes, there'll be several other components that we're going to work through as well. Now, from the PN junctions, we really break into 3 separate categories. And I'm just going to go like this. I'm going to move down, and I'm going to put a line across here. And this is going to break up into 3 like this. Okay. So what are the 3 things that we go into from essentially from PN junctions? Well, we're going to talk about specifically diodes. And the second type of component that we're going to deal with is transistors. And we're going to look at quite a number of different types of transistors, and we'll expand that knowledge probably a little bit further than what you've looked at it in previous years. And the third category, which is going to be right over there, is a group of components that we call thyristors. And the thyristors operate, of course, they have a different purpose. They operate quite a bit differently than just diodes or transistors. And so those 3 categories, are kind of where we're going to go from the PN junction. Okay, let's start with the diodes. I'm going to continue on down through the flow. From the diodes, what we're going to do is we're going to look at a little bit a specialty diode that is called a Zener diode. Some of you'll recall that name, Zener diode. And we're also going to move into just pretty much what's referred to as a simple diode. Okay, very straightforward, just a PN junction diode. And what we're going to do is a large part of the focus of this year is going to be in dealing with rectifiers, rectified power, a large part of the application of electronics as a subject area in the trade. And so lots and lots of use of for power supplies, rectified power supplies. So DC power being basically being converted from AC. So many different pieces of equipment are going to use this. So from the simple diode, we're going to start by breaking this down into two main categories, and it will be a review of single phase rectifiers, which we should have actually had some experience looking at in previous years. And then we're going to move on, and now that you have the basis of three-phase systems, we're going to work on three-phase rectifiers. And we're going to spend quite a bit of time, quite a bit of detail on those, and we're going to do some labs together on those. So the rectifiers, a very important part, and they of course fall under diodes as a group of components. Now, under transistors, we're going to do a little bit of transistor review, and just remember that these essentially came in a couple of different flavors. One was N, P, N, and the other one was P, N, P. Now, as you can see, these are really just glorified PN junctions with an extra layer on one end or the other. So it was a PN with an N on one side, or a PN with a P on the other side. And so now we're talking about three layers, three-layer devices, and we're gonna review those circuits and remember how they worked. And one of the reasons we're going to go into that and spend quite a bit of time with that is that the transistor really lays the foundation for understanding what is going to happen with an SCR, silicon controlled rectifier, which was one of the thyristor group. Okay, now in addition to that, we are also going to add another very interesting type of transistor, which is referred to as an IGBT, and that's insulated gate bipolar transistor. Okay, insulated gate bipolar transistor, IGBT. And we'll be looking into quite a bit of detail on how those work. Now, the other transistors that we will be reviewing will be the JFET and the MOSFET. Okay, so those are two transistors that we'll be reviewing, and one of these is actually going to be part of what is used to create an IGBT. So very interesting how that is going to go together. Now, when we move to the thyristors, what I'm going to start you off with is just a quick list of the thyristor family. Okay, it's a family of components, and the very important one that we're going to look at, we're going to spend quite a bit of time on, is the SCR. But just before that, I'm going to put here, this is also an SCR, but it's an LASCR, which is a light activated SCR. We'll also be looking, of course, at the SCR, okay, just a regular SCR. We will be looking at triacs, diacs, and another component that is fairly similar to a diac, which is a UJT. Okay, those are the thyristor family group of components that we're going to be looking at in a certain amount of detail. Now, what I want to do is I'm going to expand this a little bit, and I want to show you specifically what we're going to do under under these thyristor group of components, particularly under the SCR. All right, under the thyristors, um, let me show you how this splits up, and this should give you a pretty good idea of where we're going. Now, under thyristors, these break down into two main categories, and so I'm going to show it to you like this. Now, these are called trigger devices. And these devices on this side are going to be, these are going to be the devices that are going to control when the pulses are going to be received on the gates of the controllers. So these thyristors are broken into two different groups. What we have is controllers. Now the controllers are going to be used to actually control the load circuit, and the trigger device will be the device that specifically kind of meters the little pulses that are needed to turn the controllers on, and in some cases off. And so these two types really work together. These are the diex and the UJTs. Okay, so the diex and the UJTs are the trigger devices that control the small pulses. And those pulses are supplied to these devices, SCR and the triac. Now, the triac is a very interesting component. It's pretty much purpose built for a certain sort of amount and class of current. There are a lot of similarities between triacs and SCRs. I'm going to explain that to you later. But right now, what I want to do is I want to show you how the SCRs are separated sort of by purpose. And so the first thing that we're going to look at when we start on the SCRs is we're going to look at taking that SCR and using it in a DC circuit. A DC circuit. So with a DC supply, what does an SCR do? Well, it becomes a solid state switch, a solid state switch. And now we can also take the SCR and in a number of different ways, we can use it in an AC, with an AC supply. So let me show you this first. Over here we see this is going to be AC supply, and we're going to use a single phase controllable, I'm just going to show that with a C, rectifier. So it's going to be like a single phase rectifier, but fully controllable from 0 to 180 degrees. So instead of like a typical just a diode single phase rectifier, where we basically conduct for the total positive alternation of 180 degrees. Now we're going to be looking at a situation where we can literally control when that waveform, like when the SCR turns on, and literally how much load waveform we get. Very, very interesting. Now the next category will also be used in AC, and this category is used in AC as a single phase AC in, and it's going to be a full wave controllable rectifier. And this first one is a half wave, and the second one is a full wave. The next thing we're going to do with them is another AC application, and this is what we use this in AC, and it's for full phase control. Full phase control. Okay, this would be in a single phase circuit. Single phase, full phase control. And then this will be one of the last applications we'll look at. And over here, we see this. We're going to be also again in with an AC supply, this time 3-phase, and we'll be able to achieve full phase control. Full phase control in 3-phase. And so all of those different applications using the SCR, we're going to explore. Now, there are a couple of more things that are involved in the electronics subject, and so I'm just going to clear this off, and then I'm going to talk about those. All right. So in addition to everything that I've just outlined for you, there are two more things that we're going to introduce in the third year electronics section. And the first thing, now these are kind of different, I would say. They're sort of standalone away from the actual components that we're going to go through. And the first one is we're going to explore number systems. Number systems. And there are a great many number systems in use in different areas of technology and math. But in our case, we're really only interested in 3 or 4 of them. And of course, we always compare to the decimal system, base 10, this one we're instinctively kind of used to using. So we will talk about base 10 decimal. Now, there's another system that we also use, and there are applications for it, obviously, in the material that we're going to be looking at. And so base 8 is one called octal, and this one is definitely something that's used in when you're dealing with PLCs. So the base 8, good to have a knowledge of it. And another one that we all are quite familiar with using in many different ways, although we don't always recognize exactly what it is. But base 2, which is binary, and this, of course, is digital information, ones and zeros. Okay, and so this one, obviously, anything to do with processors, computers, data transfer is going to be expressed in ones and zeros. Now, there's one more that the applications are actually quite interesting. Lots of applications for it in the trade, especially if you get involved in troubleshooting at some point. Fault codes are very often generated in this base. This is base 16 or hexadecimal. Now, what we're going to do is we're going to, I'm going to go through a fairly brief description of those systems. We're going to become familiar with converting from one base to another base, and so I think that will be quite an interesting bit, but that will be a little later on towards the end of the electronics course. All right. Now, the final sort of piece of information that we're going to have that we need to cover and get familiar with. I'm going to give you a brief introduction, and it is called digital logic. Digital logic. And with digital logic, what we're really looking at is um, there are a number of types of solid state uh, integrated circuit components. And what we want to just do is we want to get a brief idea of what these gates, as they're called, how they operate, okay? And I'll just give you a little bit of a teaser here so you can see that right there would be an AND gate. This right here would be an OR gate. This right here, a NOT gate or an invert. Okay, and I'll be showing you, these are kind of the basic ones, and we'll be doing a few combinations, and I'll be showing you how to put them together and how to apply logic to them to create truth tables. And that's how we can predict what they're going to do when we place them into an electrical circuit. Very, very interesting to look at. So these are the basic shapes of the symbols, and we're going to be going into that. Like basically, that'll also be probably just it'll be a one day bit of information. It'll be close to the end of the electronics section as well. So looking forward to making our way through this. Quite a bit of material there, so we're going to try and do it in a very organized way. And looking forward to covering this with all of you.